Okay, so we got our cosecant and our sine, our reciprocals. Cosecant is 1 over sine. Secant is 1 over cosine. We want to have those down. Okay, and we went through some numbers. And actually, let's go back here. Obviously, you're not going to make this whole list every time. The key is where the zeros and the asymptotes are. So for cosecant, we have at 0 we have undefined, and at pi we have undefined, and at 2 pi. Okay? And then the zeros are in between there. And then the other useful points are these points here, where we're going in 1/6 of the distance. So this is 1/6 of the distance between the asymptotes. Okay? Going 1/6, and this will be twice the amplitude. This is our amplitude A. This will be 2A. Okay? So those points are a little useful, so we don't just have, scribbly U's. Okay? I'm not going to stress too much about did you find those perfect points when we're checking graphs and things like that, but we'll work on getting those approximately right. Okay? It's always in 1/6 and 1/6 because of the pi over 6 thing. Okay? And what was this graph here? This is the graph of y equals, let me get it color-coded here. Okay, the blue graph is y equals cosecant theta. And what is the green graph? Very good. Excuse me. Y equals sine theta. Okay, so sine helps us to get cosecant. Okay, we all go with y now because of the reciprocal thing. Okay, so if you don't graph the whole sine, it's useful to plot 1, 2, 3, 4, these points here. Okay, plot those points because those tells you, yeah, they tells you the asymptotes and they tell you the minimum maximums. Okay, so if you go and just plot all those points for sine, you're all ready for asymptotes and you're ready for the u's. All right, and I think you's got it. All right. So we ran short on time, so we crammed this in here, pretty sloppily like. So let's just, what is that? Okay. So if we look at it in terms, or look at secant now, okay, we can do the same thing. I'll just kind of quickly, secant's 1 over cosine, right? And so we want to find out, when do we get these values the same? Well, it's when secant and cosine are 1. And what angles give us a cosine of 1? What do we get a cosine of 1, Adam? Where in our unit circle do we get a cosine of 1? What's that? 0, you got it. Okay, so that's when theta is 0. We get a cosine of -1. That's what that's all about there. Cosine of -1 over at pi. So when we're over here at pi. All right. So those are the angles that give us a problem. Oh, I'm sorry. That's when they're the same. And when is it undefined? Well, it's undefined when cosine is 0. And cosine is 0 when it's straight up or straight down. Okay? All right. And the signs are positive because we said reciprocals have the same sign. All right? Have the same sign, S-I-G-N. All right. So let's just kind of put all that together real quickly. Cosine, what is cosine at 0? Adam just said cosine is at 0. Cosine was 1, right? So at 0, cosine is 1. At pi, cosine is -1. And at 2 pi, cosine is 1. So what's true about its reciprocals? Same thing. Okay. And when is cosine 0? Straight up and down. So straight up, straight down. And when cosine is 0, secant is undefined, right? Okay. And then we have these values that are nice. Pi over 3. What's the cosine of pi over 3? is 1/2. That's right. So cosine of pi over 3 is our x value there, which is 1/2. Well, that's nice because the reciprocal of 1/2 is really easy. 2. And the cosine of 2 pi over 3, -1/2, right? So -1/2, which is -2 reciprocal. And same story for these other guys. -1/2 reciprocal is -2. 1/2 reciprocal is 2. Okay, so those are just useful, easy reciprocals. Okay. Note, by the way, what's the distance between pi over 2 and pi over 3? What's that distance there in radians? Or what is this angle in degrees? That little angle right there. It's a 30-degree, right? So that's a 30-degree angle. So this is pi over 6. That distance, that little distance there. That makes sense? Okay? Because the reason why I point that out is because remember this little distance right here? That's pi over 6. And this is pi over 6. And this is pi over 6. These points are always pi over 6 from the asymptote. And it's going to be the same case here. Okay? And we graphed this quickly as we ran out of time yesterday. Okay? But step 1, this should be step 1. Plot cosine. The key is plot cosine, or at least the key points, the critical points here, the minimums, maximums, and zeros. Okay? We draw the asymptotes at the zeros. Okay? And then step 3, we plot the order pairs, theta secant, okay, on the interval 0 to 2 pi, okay. So the key points are where they are 1 and -1, because they're the same. And then to find these points, these other points, I'm trying to make this straightforward as possible. We had these other points. They were at pi over 3, right? Yeah. No. Yeah, pi over 3. This is pi over 6. This is 2 pi over 6, which is pi over 3. If we put pi all the way out there. You see that? Okay. So 2/6 of a pi. Okay. We're going to be up at 2. This is 1. This is 2. It's just twice the amplitude, by the way. Okay? If the amplitude's 1, that's going to be up at 2. But again, notice this distance. It's 1/6 of that gap. Okay? And this one's going to be up here also at 2. And the positive and negative sign is always the same. We come in 1/6 of the way and 1/6 of the way, and we have this. Okay. Come in 1/6 of the way, and we're twice the amplitude. Twice the amplitude. Okay. So on and so forth. So that is y equals, this is cosine, so this is secant, right? There we have it. Okay? So let's real quickly analyze it. What's the domain for these? For cosecants, what can x not be for cosecant? Cosecant goes with the sine. We have to ask ourselves when sine is 0. So when is sine 0? That's at 0, right? And then every pi multiple, right? Okay. How about secant? Well, how about let's do this. Let's go down and do cosecant, and then I'm going to let you think through secant. Okay? Range. What's the range, the y values that we can get out of cosecant? There it is. That's cosecant. Yes. What's the y values we can get? Can we get a 1 out of it? Yeah, we can. Can we get a 0 out of it? No. Can we get a half? No, no. We get 1 and above, right? Or -1 and below. Remember how to write that? Parenthesis from -infinity up to -1. And then union, right? From 1 to infinity. Okay? And where do we have asymptotes? Well, everywhere that was not allowed is an asymptote. Where do we have zeros? Anywhere? Do we have any zeros? Does it ever cross the x-axis? No, none. Okay? Minimums and maximums? Well, we have locals. When do we have local mins and maximums? Okay, good. The y values are there. When do we have the x values? At what x values do we have minimums and maximums? Pi over 2, -pi over 2. So pi over 2 and every pi after that, right? Okay. So pi over 2 gives us, plus, we should say, plus pi k. Okay. Symmetry, is it odd or even? Can we fold it? No, that's even. If we can fold it onto itself or flip it this way, that would be even. So it's not even, but can we spin it? We can. Okay? By the way, sine is odd, so cosecant is odd. Okay? So this is odd. And last but not least, what's the period? Be careful. The horizontal distance required for it to repeat. It's 2 pi. It seems like it should be pi because the gaps are pi, but this doesn't repeat for 2 pi. It's 2 pi away. Okay? So it's 2 pi. All right? And why don't you take a moment together and do the same thing for secant. Pair together as you go.
Oh, it's like more the asymptotes.
Kind of quick there. No, go ahead and what you have, share with your group. Some of you have the first half, some of you have the second half. Go ahead and compare for a second. All right, let's check it out together here. We have domain. What's a domain? When do we have problems? X cannot be pi over 2. Good. Okay. Plus pi k. All right, so it can't be pi over 2 and every pi after that. Range? Same thing. You guys agree? Okay, so, and we shouldn't be surprised because secant and sine and cosine are just shifts of each other. Asymptotes, well, that's wherever this cannot be. Good morning. How you doing? All right. Good. What you need?
the TI Smart View?
Yes.
Do you have that?
I have a copy, Sean has a copy. Let's see. License-wise, I don't know what matters. This particular one was my personal one, and then Sean has a department one. So, is that what you're looking for?
Yes.
Calculator emulator?
Yeah.
Okay.
He had it on his current machine.
Oh, okay.
Just, Cloud Scan.
Okay.
So, we're looking to get him upgraded.
Okay.
Let me put on software, so.
Yeah, so Sean has the department one,
Okay.
as far as the license, all that.
Is that
So
right?
Sean Gross is right over there, yeah. One, two, third one down.
All right. Thank you.
Okay, thank you.
Yep.
If that doesn't work, I mean, I'm sure it doesn't matter, because it's not a limited license kind of
Okay.
thing, so
All right, thanks.
take this one. All right, so zeros, again, none. Sorry about the internet. Okay, minimums and maximums, where do we have those? Good. What'd you say, Ella?
I said 5 plus 5 is 2.
Pi, oh, is it
Yeah.
pi, good, sorry. I can clean my ears out. Plus, pi over 2, how often does it repeat there? We're talking about minimums and maximums. How far away is this one? Pi, right? So is that what you said? So pi plus pi k, yeah. Okay. I think I just didn't hear you right there. I'm getting old. Gotta clean the ears out. Symmetry, even or odd? This one is even, because you can fold it, because cosine is even. And that, by the way, this will matter more in calculus than now. Okay, right now we're going to point out, and next year, if those of you that take calculus say, oh yeah, that's right. Okay, you can fold it in half, it's even. Okay? All right. Actually, it'll matter for us soon also. And period is 2 pi. Okay, cruising along here. So transformations are all the same because, hey, it all depends on the sine and cosine. Okay, so same story as sine and cosine here. A is the vertical stretch. Again, these are probably our last graphs, by the way. Okay. So of the year, this is our last. We got one more that we'll look at here in a little bit. So anyways, you should be seeing by now, this is the same story. I'm sick and tired of it because functions act the same. Okay? So B is what's our B value? Tell us. What does it do to the graph? What does it do, Kate?
It affects period and horizontal stretch.
Good, you got it. Okay, horizontal stretch, and the period is just like sine and cosine, 2 pi over absolute value of b. Okay? All right, h is the horizontal or vertical? Don't know, what's h do? Horizontal or vertical? All right, and we're going to go with that. That sounds good. Horizontal shift, okay, or translation. Okay, and k is the other way, right? Vertical shift. All right, and here's the key to graph cosecant. First, find the zeros, minimums, maximums of the sine function. To graph secant, graph the zeros, minimums, maximums of the cosine. Okay? So, that's the idea. Let's look at two quick ones here and then give you that. What is the companion function to 3 cosecant x? 3 sine of x. So we're going to think about, we need to change this scale too. That's going to be a problem. How about, let's change this to 3, 6, 9. Okay. 3, 6, 9. That might feel weird to do 2 squares for 3, but you'll see in a second it's all good. Okay. So plot the zeros and the minimums and maximums for 3 sine x. Going up to the right and down to the left. If you want to dot in the function, goodness gracious, then you can, but we don't need it. Okay, you see the sine wave? Where's the asymptotes? Okay, pi over 2 Novatron. Because this is 3 times 1 over sine x. So when sine x is 0, we have an asymptote. So try again. Where's an asymptote, Emily? At 0? Is that what you said? Okay, at pi. Say it nice and loud. What did you say?
I said what?
What? Where is sine 0? At 0. And at pi. And at 2 pi. So on and so forth. Okay, so everywhere sine is 0, we have an asymptote. Okay. And at the leftover dots, that's where sine and cosecant are the same. Okay, so we know it's going to go up, where the dot's up, down where the dot's down. Okay, we can find our other points by coming in 1/6 of the distance from the asymptote, 1/6 both ways. Okay. Now you might note, hey, that looks a lot like what we did before, but here the amplitude is 3, so the value of cosecant here is up 6, twice as far as the amplitude, twice the amplitude. Okay? So n a 6th on both sides, and we get our graph. N a 6th so we come in 1/6 both directions and double the amplitude. And that'll give us our basic shape. Okay? Okay, that was cosecant. You know what? Let's change this one. Okay? Unless you already did it, did you already get into it there? Let's do this as secant. Okay, we did one cosecant, let's do one secant. Okay. So change it to y equals secant of 2x minus 1. And what companion function should we graph? Cosine. Secant is 1 over cosine of 2x minus 1. And what does that minus 1 do? Is it up or down, right? So in this case, down, yeah. You got it. Okay. So we know the whole thing's going to shift down 1. Amplitude is 1, so this should work. Positive 1. So the whole thing's going to shift down 1. You could do it 2 squares or 1 squares, your call. Okay. You don't have to put that dotted line in there, but it might help. So that's like our shifted axis. And the period, what's our period going to be? 2 pi over 2, which is pi. Yep. And so let's think about cosine. Cosine starts up on the x-axis, 1 unit. Right? So cosine goes up from our new shifted axis. Our period is pi, so at pi we're going to be right back where we started. Okay? And then we need to split that into 4 parts. Okay? And so we're going to be at our shifted 0 here, here, and back up. There's our shifted cosine curve. Okay. Again, we're splitting into 4 parts there. We have a 0 or a shifted 0, a minimum, a 0, a maximum. Split into 4 parts, 0, minimum, 0, maximum. Okay? If you want to dot in the curve so you can see it, there you go. Okay? Where's the asymptotes? Are they at the real zeros up here, which 0 pi in there? No, the shifted zeros, right? So those are not our asymptotes. Our asymptotes will be at the shifted zeros, which is at, looks like pi over 4, 3 pi over 4, so on and so forth. Okay. And that'll be enough. We should see our U shapes are going to go up and down here. You can think, all right, we're going to come in a sixth. Well, up here about a sixth of the direction, we're going to be up from our shifted asymptote. Don't worry too much about those extra points, but it should give you an idea of where you should be. In a sixth, double the amplitude. Okay. All good? Hola, senor.
Future calculus studs.
Future calculus studs.
I like it.
Cranking out the secants.
Guess what? We, calculus studs, are going to be paperless iPads.
That's right. So you better get
This is
used
good.
to it.
It's going to be way better than what he's done.
That's right. Way
I
better.
don't like,
Way
I
better.
don't like papers.
I spent all day at Summit High School in Bend and observed calculus and pre-calculus with the iPad stuff.
I have a lot of trouble with papers.
Really?
Yeah, not good at technology.
You're not good with technology?
I mean, I can do some, but.
Oh, we're going to make this idiot-proof because I'm an idiot, so if I could do it.
All right, flip the page and try those next few there.
I'm helping Johnny Q with this.
Yes.
Johnny Q. I'm not sure, can you do this without quadratics?
10 over, well, good question. 10 over x plus 2 and 10 plus x
Right.
over, oh goodness, I didn't realize that. No, scratch it.
Okay.
Can it?
Okay, I didn't know if you.
No, I
Okay.
didn't. I looked that close.
Yeah. All right, cool.
Thanks, man. Okay, take a moment right now and let's